Hello again, folks. We're going to take a look now at number 3 from the Unit 6 quiz. So they're asking us to sketch this graph. And at this point here, you should be recognizing that this graph will have something that has a sinusoidal look to it, in that there is going to be a repetition, but it's going to live in between this function it's being multiplied by, which in this case here is a decreasing exponential function, and it's going to live above the negative of that function. Okay, and the reason is that sine is only going to spit out numbers between -1 and +1. So at the very most, this whole function is going to be equal to 1 times 0.9 to the x, so the function itself, or -1 times 0.9 to the x, so it's going to be just the negative of that function. And everything else is going to be in between, because it's going to make the products closer to 0. Okay, so since there's going to be this repetition that comes from the sine function, the first thing I'm going to do is determine the period of this function. So the period is just 2 pi over 2. Okay, pi's cancel out, so 2 divided by 1/2 is just equal to 4. Okay, so that gives me now my period. And again, you want to think of splitting up this period into 4 equal parts. Okay, now you know that this function here is a decreasing exponential function, so its maximum possible value in the interval that I'm looking at is going to occur at -4. So what I'm going to do is I'm going to determine 0.9 to the -4 so that I can figure out what kind of scale I should use on my axis. I already know that I have to go from -4 to 6, so that's going to help me determine my x-axis. In order to determine my y-axis, let me figure out the biggest possible value this is going to have. And since again it's a decreasing function, it's going to occur on the left-hand side. Okay, so let's calculate 0.9 to the exponent of -4 is equal to just over 1.5. Okay, so that means I'm going to go up, definitely by more than a box for 1 unit. Okay, so let me start by my x-axis. Okay, now this was, cleverly chosen so that you can fit exactly all the units here. So if this is -4, 3, 2, 1, 0, okay. There's my y-axis. Okay, and 1, 2, 3, 4, 5, 6, and to -4 perfectly fits onto this graph. Okay, now in terms of my y-axis, we said that this goes to about 1.5. Okay, so here I guess I could, make 2 boxes equal to 1 unit. Okay, but that means I'm only going to go up to here. So I'm going to make 3 boxes, okay, equal to 1 unit. So 1 and -1, okay, and I'll have to keep in mind. Okay, so next thing we'll do is we'll take a look at when this expression here is equal to 0, when it's at its max, and when it's at its min. Okay, so when is sine of pi over 2x equal to 0? Okay, well, when x is equal to, I'm not going to bother solving this because I have the period. Okay, so I know it's going to be equal to 0 at 0. Sine of 0 is equal to 0. Okay, it's going to next be equal to 0 halfway through its period, which in this case here is 4, so it's going to be 0 at 2. Okay, and then again at the end of its period at 4, and then at 6, and that's as far as I need to go. Okay, and if I go to the negatives, well, when else is it going to be equal to 0? Well, it's going to be equal to 0 at -2 and at -4, and that's as far as I have to go. Okay. Now the other important points that are going to help me draw this function is when is it going to be equal to 0.9 to the x, and that's going to be when sine pi over 2x is at its maximum. Okay, so it's going to be at the maximum value. Okay, when x is equal to, well, if it starts at the middle, it's going to be at its maximum, okay, midway through this here. So it's going to be at a max at x equals 1. Okay, the next time is going to be at its max is going to be one whole cycle after that. So 1 plus 4 is 5. Okay, and that's as far as I need to go, because if I add another 4 units, I'll be past my domain. Okay, and in the negative, so I'm going to do 1 minus 4, so at negative 3. Okay, and that's as far as I have to go. When's it going to be at its min? Well, it's going to be at its min. Okay, think of the sine function. Again, always think of it in 4 parts. Okay, so 1/4 of the way it was at its min, 3/4 of the way, sorry, its max, sorry about that, 3/4 of the way it's going to be at its min. Okay, so 3/4 through its cycle is going to be at x equals 3. Okay, if I add 4 to that, I'm going to be beyond my domain. Okay, if I go into the negatives, well, it's going to be 1/4 to the left is when it's at its min, so that's going to be at negative 1. Okay, so these now are all the important points on my graph. Okay, so let me start by plotting my x-intercepts. So my x-intercepts, we said, were at negative 4, negative 2, 0, 2, 4, and at 6. So these are going to be all the zeros. Okay, now when sine pi over 2x is equal to 1, okay, it's just going to be equal to 0.9 to the x. So this is where I'm now going to take my calculator and calculate. The first time it's at its max is at negative 3. Okay, so here we have 0.9 exponent negative 3 is about 1.37. Okay, so that means that at negative 3, it's going to be exactly equal to 0.9 to the x, so about 1.37. Well, remember, we'd end up 3 boxes, so that's about 1.33, so it'll be just above that. Okay, now it's going to reach its min at negative 1. So at negative 1, the whole function is going to be negative 1 times 0.9 to the x, okay, which the first min, of course, is at negative 1. So let's calculate 0.9 exponent negative 1, and we get 1.11, okay, and then, of course, that's time negative, so it's negative 1.11. So here we've got negative 1 here, so it'll be just a little below that. So there will be a point. Okay, then it's going to be at its max again at 1. Okay, so here 0.9 exponent 1 is just, of course, 0.9. So here 0.9, so this is 0.66, so 0.9 will be somewhere here. Notice I'm not being that, as long as it's reasonable, that's fine. So the next time it's going to be at its min at 3. So we got 0.9 exponent 3. Okay, and of course we have to take the negative of that. So about negative 7.3. Okay, so here this would be negative 6.66, so 7.3 will be, probably somewhere there. Okay, and then finally it'll be at its max at 5. So 0.9 exponent 5 is equal to about 0.6. So here 0.6, this is 0.66, so 0.6 should be just below. Okay, and now I've got enough information to draw my graph. Okay, because now we know it's going to go up to this value here and come back down to 0 and go down to this local min, back to 0, to this local max, back to 0, and it's going to continue this behavior. Okay. Now the other thing that I could draw here, so notice it says any other curves to help show the behavior, is I could show that this function 0.9 to the x kind of acts like a boundary at the top and at the bottom. Okay, so it is kind of nice to draw this to really show that this function is going to lie between those two functions there. Okay, but just to recap, okay, you want to find the period of your sinusoidal function. You want to determine when that sinusoidal function is equal to 0, when it reaches its max, when it reaches its min, and then from there use that to determine these local maxes and mins, okay, along with your zeros, and you'll have a nice graph. Okay, that's it for this one.